We are talking about the possible ranges of sine and cosine. We just did a little experiment where we took any number that we wanted to and we took the sine of it and we found out that it always came out between -1 and +1. We did the same thing with cosine. Plug in anything you want for a number for cosine and whatever it spits out will be a number between -1 and +1 again. Now, can you think of why that is, though? If you look at, let's just take a look at any old right triangle, right? So let's say this is my angle. Remember that, so this would be the adjacent side, this would be the opposite side, and this would be the hypotenuse. When you are going to find the sine, isn't sine opposite over hypotenuse? Right? Right? That's how you find sine, is the opposite side divided by the hypotenuse. So think about that. If I do this number divided by this number, doesn't it make sense that it could never be bigger than 1? Because what's true about this side? What's true about the hypotenuse in a right triangle? It's the longest side. So this side, whatever it is going to be shorter than that one. So I'm never, in other words, going to end up with an improper fraction if I'm doing sine. No matter what shape the triangle is, if I do the opposite side divided by the hypotenuse, this number has to be smaller than that number. So that's how I always end up in that range between a -1 and a +1. Okay, look at cosine. Adjacent over hypotenuse, you end up in the same thing, right? Because I'm always doing a smaller side divided by a bigger side. So I'll always be, I can't get above 1, because that would mean that the adjacent side would have to be bigger than the hypotenuse, and that's impossible. Does that make sense? But now let's talk about tangent. What did you notice about tangent in your trig tables? Were you getting all sorts of different values for tangent? Try the same thing. Take tangent of a bunch of different numbers on your calculator and just see what comes out. I took tangent of 50. I already got a number above 1. Try a bunch of different ones. Wow. Look at this one I did. I did the tangent of 89.99999. Look at this number that came out. Wow. So, are you finding any kind of a pattern with tangent? No. They can be anything. They can really be anything. Why? Because think about what tangent is. Isn't it opposite over adjacent? So, and there's no relationship between, like, it's not guaranteed that one of these two is going to be bigger than the other. Like it is, we know the hypotenuse has to be the biggest side, but opposite and adjacent, if I'm comparing these two, there could be any relationship between them. This one could be bigger, that one could be bigger, doesn't matter. So when I go and I do the workout, it turns out that tangent can be anything it wants to be. So, tangent and cotangent, because it's just the reciprocal, right? These two can be any real number. Because again, it's just that opposite side divided by the adjacent side, and since those two can be any numbers, that's what I'm going to get out. Now, for secant and cosecant, this is a little bit more involved. So let's just look at secant for a minute. So secant is the reciprocal of cosine, right? Right? Secant and cosine go together. So if you recall, cosine could be anything between -1 and +1. So let's just say for a minute that the cosine is 2/3. What would the secant be? If this one's 2/3, that makes this one What's the reciprocal of 2/3? 3/2. Well, 3/2 is 1.5. Oh, that's interesting. So it's already out of this range for secant. Okay, so let's pick another thing. Oh, I don't know. How about, let's say that the cosine was 8/9. Take the reciprocal, now it's 9/8. My gosh. It's already bigger than 1. Let's go in the negatives. What if it was negative 4/5? Well, that reciprocal is now going to be negative 5/4. So basically, when you take the reciprocal, it's everything except this. Isn't that interesting, right? Because once you take the reciprocal, you're out of this range now. So secant is going to be, secant of some angle has to be less than or equal to -1, or it can be greater than or equal to -1. It's the exact opposite of its reciprocal. Same thing happens with cosecant because we were in that same problem. So cosecant of some angle has to be less than or equal to -1, or greater than or equal to +1. Does that make sense? Okay. Because if I'm starting with a number that's between -1 and +1, if I take its reciprocal, it is no longer in that range from -1 to +1. It's outside of it, so that would cover all the numbers outside of that range. All right, cool. So if you look on the next page, now the directions are here, sorry. Determine if each statement is possible or impossible. So based on what we just talked about, could you have a cotangent equal to -0.99999? What did we just say about cotangent? Did we actually write it down? Yeah, kind of. Both of them can be any real number. So could I have a cotangent of -0.999? Yeah, because it can be anything. So yes, this is possible. How about the next one? Is it possible to have a cosine that's -1.7? No, that is impossible because cosine only goes between -1 and +1. And how about the third one? Can you have cosecant of 0? No, right? Because remember, cosecant has to be less than or equal to -1 or greater than or equal to +1. And 0 does not fit into either of those, so that is an impossible value. Okay, does all that make sense so far? All right. So the next thing I want to look at, let's just see if we can get through F and G, and then we'll be done. All right, don't worry about the Pythagorean or quotient identities. We're actually not going to do identities. So jump down to F. All right, so let's look at what I have here. It says find cosine and tangent given that sine is that. All right, so earlier in this chapter, if I was given sine, I could find cosecant because they're reciprocals of each other, right? Or if I was given tangent, I could find cotangent. But here, I'm given sine and I'm not asked for cosecant. I'm asking for cosine and tangent. Well, lucky us. If we sketch this, we actually have a lot of information here. Let's make a little sketch. And let's remember what sine is equivalent to. And if you have your reference sheet, I think some of you were out when I handed out the reference sheet, so I'll give you one in a minute. So if you look right here, sine is equal to y over r. So I have those two values. I have y and I have r. All right, so check this out. This is y, this is r. So here's what I can do if I kind of sketch this. All right, the y value is going to be a negative root 2, which is just some value, right? But I know that I'm going to drop down to make it negative root 2. R could be anywhere, right? Because remember, r is just always positive. Doesn't matter what quadrant I'm in. However, I do have this information right here. Cosine has to be positive. So let's remember, all students take calc. What quadrants have positive cosines? In what quadrants will I find positive cosines? First one, because everyone's positive there, and the fourth, right? All of them, sine, tangent, cosine. So I'm not dealing with this because I know cosine has to be positive. And then this gives me the other clue. Since y is negative, that means that I'm actually in quadrant 4. You see that? So what I'm going to do is I'm going to sketch for myself a triangle in quadrant 4. Doesn't even really matter where you put it, but I'm going to label the pieces. I know the y is negative root 2. I know the r, remember that's really the hypotenuse of your triangle. That's 3. Couldn't I solve for this missing value? And then once I have that value, can I find cosine and tangent? You bet I can. Remember, here's my angle. It's always the one with the vertex at the origin. So now let's just do Pythagorean theorem and solve for that one missing side. Make sure you're putting in 3 as the hypotenuse. So I'll call you x because I don't know what you are. So x squared plus negative root 2 squared must equal 3 squared. Is this okay so far? Everybody's all right? All right, now I can just solve for x, right? What do you get when you have negative root 2 and you square it? What comes out? Yes, positive 2, right? Because a negative squared turns into a positive, and root 2 times root 2 is just 2. Oh, for Pete's sake. These, Staples brand mechanical pencils. Garbage. Or maybe I'm just too forceful. I don't know. But I tell you, using a Bic pencil, I don't have nearly as many breaks. Okay, square root both sides. Now, is it going to be positive root 7, negative root 7, or both? Look back at your diagram because that's going to give you a... Yes. So mathematically, right, if I just asked you to solve this math problem, you're right, I'd have both roots. But remember what it's referring to. It's an x, and I'm in the positive direction. If this same triangle was over here, then I would have taken the negative root, right? So it kind of matters where you are. So since I'm in the positive x direction, it's just going to be a positive root 7. And now I can go ahead and find cosine and tangent pretty easily. So cosine will be adjacent over hypotenuse. So root 7 over 3. And tangent, opposite over adjacent. So negative root 2 over root 7. But then I'd have to fix it by doing what? Yeah, times by that root 7. Can I reduce the 14 and the 7? No. One's in a root and one's not. So you are not allowed to touch them. They either both have to be in the root or both have to be out of the root. You can't have one in, one out and reduce them with each other. So there is my tangent value. Does that make sense? Is this all right? Okay, so let's kind of try G. I'll help you get set up with it a little bit. This time they're giving me cotangent. Okay, that's interesting. I'm supposed to find sine and cosine. But what they did tell me this time is that they just came right out and said what quadrant I'm in. So that makes it a little bit nicer. I don't have to go through all the thinking. So I know I'm in quadrant 2. So I'm just going to draw for myself any old triangle in quadrant 2. Now, cotangent, if you look at your reference sheet, cotangent is x over y. So that's what they've given me, the x and the y values. Okay, x and y. So my x is -7, my y is +24. So then I should be able to finish this, right? Find that hypotenuse, and then I can find sine and cosine. All right, everybody try it. I'm going to do it up here on my sheet too, but don't look up at my screen until you did it on yours, and we'll see if we all match. Oh, it broke again. I'm telling you, this is just crazy. Oh, this was dumb. It's a Pythagorean triple, silly goose. How did everybody do? Check and see if you got the same things I got for sine and cosine. How did I know that this was going to be the positive value? Why didn't I do negative? Lily? No, r is just the variable I used for, because that's usually what we use for that side, and then 25 was my answer for r. Sorry. R, remember, is just a distance. R is always positive, no matter what quadrant you're in. It's x and y that could be positive or negative, depending where you are. Does that make sense? Okay. All right. So I think that's it for 1-4.